Greetings all. Welcome to the outreach program of IRRD Automatants. This series of workshop handles the design of circuits in digital and analog based on FinFET transistors. As we all know that the short channel effects in the CMOS devices below 35 nanometer, or we can say that below 45 nanometer, is troublesome, and it leads to different second order effects like VT roll off, DIBL, leakage current problems, and the other problems includes the subthreshold leakage, gate induced drain leakage, and etc. So the FinFET is going to replace the CMOS devices below 45 nanometer, but the CMOS devices also will play a vital role for high-speed devices. This series of lecture or workshop or hands-on program will help the viewers to understand the role of FinFET in the modern VLSI, and the FinFET is replacing the CMOS devices in analog and digital. And this series of workshop will discuss about the advantages of the FinFET devices and the structures of the FinFET, what are the different modes of the FinFET devices, what are the configurations, how the FinFET can be worked in shorted gated, independent gate, and low power modes, and how hybrid boards can be designed for different circuits, and the different type of like what we are seeing in the shorted gate mode of inverter. The same will be applicable to different circuits on FIR, IAR filters, discrete wavelet transforms, and different image processing application also. The viewers can able to have an hands-on experience on how the device has been modeled, and for the modeling, the model files from the Stanford University has been used, and these model files are available free to the viewers, and the experiments will be carried out through different SPICE models, and through different SPICE softwares this modeling will be done. So here the series will talks about the introduction part, and what are the different types, and it moves towards the design geometry, how to model the device, and what are the design dependency of the threshold voltage and the swing on the edge, that is the height of the fin. And it also deals with the different type of characteristics of the and how the characteristics will show us how the FinFET device eliminates the short channel effects. So this series of workshops will help the viewers to understand how the FinFET device is modeled, how the characteristics of the FinFET is enhanced when compared with the CMOS devices, how the FinFET devices is used to design different analog and digital circuits, how it has been used to design an operational amplifiers, FIR filters, DWT architectures, and for different ASICs. So this series of workshop will cover all these aspects, and the viewers will get an idea about that. So kindly subscribe on this link, and you will be we will be giving you all the technical data and hands-on experience with the modeling and the design of the FinFET devices. So as we see that in the FinFET devices, the design and other optimization has been done. Okay, so far to have a trade-off regarding the short channel effects, and how the dielectric thickness scaling has been done, and how the threshold voltage has been controlled. Okay, those things will be discussed, and we will be focusing on how the fabrication part is happening, and the different model files used by Berkeley, and the different lithographic files used for the fabrication of the device below 14 nm FinFET devices, and that has been extended to its performance, and how this related with existing methods and literature survey, and with the papers and with the models and experiments carried out in the literature, those things will be discussed, and the performance characteristics of the device with the like effective field for the whole mobility is been compared, and you can easily find that how the dependency of the drive current on the fin will be discussed, and we find that the peak transconductance of the P devices, P FinFET devices is very high because of the whole mobility of the channel is getting enhanced. Those sort of performances will be handled, and the speed and leakage, how the speed of the device when compared with the NMOS device, and for the planar bulk MOSFET devices will be done, and the characteristics will be plotted by using the live results obtained from the SPICE models and the SPICE software, and those will give us an idea about how this characteristics will impact on the ASIC and ASIC devices, which is we are going to design for any system on chip architecture. Finally, the performance evaluation will be done based on the short channel effects, and that will be compared for the NFINFET device, PFINFET devices. And as for the summary, all the things will be put together, where the investigation and the workshop models, experiments, we will come to a conclusion that the double gate FinFET can reduce the short channel effects, and the FinFET is going to lead the DGFET. Okay, so the different fabrication models and what is the properties and characteristics of the device, and how the device will be working on analog circuits and digital circuits, everything will be discussed. Thank you. Subscribe our channel for the further updation regarding the FinFET devices. Thank you.